Hello, everyone, and welcome to the second half of this section. So, this is 3.5, part 2. We're still talking about these patterns of numbers. We'll call these arithmetic sequences. So, remember, a sequence is just a list of numbers, and this word arithmetic means we're talking about numbers that are adding or subtracting the same thing. So, not too crazy. Same stuff we talked about last time. So we use that word sequence. A term is each individual number. And we'll talk about those common differences as we use these formulas. We talked about these examples last time. Just remember it can be positive, such as a positive 2 increase. And your common difference can also be negative when the number goes down. So it can go either direction, but notice if it always stays the same, then it is, in fact, an arithmetic sequence, adding or subtracting the same thing, and you have that common difference. So keep that in the front of your mind as we work through a few more types of problems today. So the first example we're going to look at today, we will call 3A. And in this problem, there are some words involved. What I would like you to have is just the numbers for the sequence, and then just say that we're writing an equation. So numbers and write an equation. So please begin writing that down as we start. So the sequence is given here. We're talking about the number of pencils some girl Claire has in her collection after she goes to her school store every week. We can write an equation for the nth term of the sequence. So starting at square one, the blank equation is where we're going to start on most math problems. And we worked through this lots yesterday, so we know this is our equation given to help us find any term we want in a sequence. So there's 4 letters here, 4 different variables. 2 of them we already know, and 2 of them we'll leave. So notice what's left in all of these. A sub n is left alone. So this won't change. And also the n stays in there too. Notice that in every one of these examples. So a sub n and n are going to stay. What we're going to take out, what we're going to change or replace, are the other 2 things. A sub 1, the first term, and d, the common difference. Those 2 things we have to know and substitute in to find this equation. So what is my a sub 1? What is my first term? Well, very quickly we can look back at the list and we see 2 comes first. So since the first term is a 2, we can replace that right here in our equation. So 2 plus n minus 1 will just stay as n minus 1. And now we need to know what is our common difference. What is d? In other words, how are these changing each term? Well, from 2 to 7, we jump 5, 5 here, again, and one more time. So each time we're adding 5. So that plus 5 is our common difference, a positive 5. So here where there's a d, we'll replace it with a 5. Okay, so we're looking good. Now notice what we've got here. We have the number 2 by itself, plus the product of these 2 things here, 5 times this whole expression. So this 5 needs to be distributed to both the n and the negative 1. So a sub n will equal 2 plus 5 times n, which is 5n, and 5 times a negative 1, which is a negative 5. So now we need to simplify this whole thing. 2 and a negative 5. If I have 2 and I take away 5, what do I have left? Well, I have a negative 3. And 5n you can't do anything with. So we should have any term we want, a sub n, will be equal to 5 times the number of the term, take away 3. So looking at our options, we see it should be no, D is correct. Now notice here, I moved the variable, this 5n, to the front because I always want to write the variable first and just regular numbers afterwards. So I did the 2 minus 5 and put that in the back and brought the 5n to the front. So this is our solution. Given the multiple choice, it is answer choice D for 3A. So make sure you have the sequence and the equation written here. That's what you need as we move past this example into another. There we go. We confirm D is correct. Okay, so 3B. We're looking at another problem with a little bit of context. So continuing off of what we just said, so remembering that our formula is 5n minus 3, it says find the 12th term. In other words, we know our formula is this. Five n minus 3. Now this allows us to plug in any number term and find out what it is. So they say find the 12th term. So we have to make our lives easy now. All we have to do is plug in a 12 where we see an n. So I'll make this a sub 12. That will equal 5 times n is now 12. And we're going to take away 3. So the 12th term equals 5 times 12 is 60. And 60 will take away 3. So what are we going to get here? The 12th term will be equal to 60 take away 3 is 57. So my 12th term has to be 57. Now notice what we did here. We took the equation that we already found. This magical equation that we found lets us find any term we want. They told us find the 12th one, so we just plug in a 12 for n. This a sub 12 thing means the 12th term, and then whatever value we get on the right is the value of that term. So the 12th term equals 57. So clearly we know of these choices we should get letter choice B. So we have that down, and A and B for this one were a 1 and 2 part problem working together. So we're good on 3B. Now 3C is continuing off of the same context. This time we're asked to graph the first 5 terms of the sequence. So there's 2 things to consider with these problems. First, your x-axis and your y-axis. So my x-axis is always going to be, let's change our color here. My x-axis is going to be n, so just the number of the term. My y-axis is going to be the terms. In other words, the list of the numbers, those are the y values. The first term, the second term, the third term. So if I was going to make a quick table of the first 5, x is just n, the number of the terms. So we'll have the first one, the second one, the third one. The x will always just be counting numbers. And they're going to say, what are the first 5? So that would give us this. Please construct this table as I'm doing it with you. So these are our x values. Notice both graphs have that, so that makes sense. Now our y values are going to be the actual terms. So the first term is what? Well, we look, the first term is 2. The second term is what? 7. The third term is 12. If we plug in the fourth term here, will be 17. And the last one is 22. So we have those 5 terms, and now we can use this to make a graph. So when x is 1, y is 2. So if I look at my graphs, and the first one, option A, When x is 1, y is up at what looks like maybe 22. And that's clearly not what we should get here. But if I look at b, if I go over to 1, I'm up at about 2. That's good. If I go over to 2, I'm up at a little more than 6, so we can call that 7. And that matches what we see here. If I go over to 3, am I at 12? Well, over to 3, up to 12 perfectly. Yep, that makes sense. 4 and 17, 4, 17, yes. And 522. So go over to 5, up, and where does this point hit? Just above that middle there, that is 22. So these points are all perfectly aligned with what is happening in the sequence. So just remember, when they tell you to graph, the x-axis is in, just the term. So here this is the term number in. The y-axis is the value of the terms, the list of the numbers. We call that a sub n. What are the terms? So the terms are given here. These are your y values, your a sub n, just the terms. That's always y. Your x values are just the number of terms, just counting numbers, 1, 2, 3, 4, 5. So keep that in the front of your mind, so when you're doing these problems and they tell you to graph, that's what they're looking for, okay? So we said B is correct on 3C. Okay, 3D. Given this arithmetic sequence, we can use the same problem with one more question to help solve. Which term of the sequence is 97? So if we go back, our formula we said was 5n minus 3. Okay, so we'll use that. So a sub n equals 5n minus 3. We know this to be true. Any term we want can be found by taking 5 times the number of the term and take away 3. So which term of the sequence is 97? In other words, if 97 is some term that we get out, that's given here, what number term is it? We want to find out what is the n value. How far along in our list is this term? So we're given this, and we want to find n. So we plug in this value for this term, 97. That's the hardest part. And that's equal to 5 and take away 3. Okay. So now we're back at, can you solve a multi-step equation, which we practiced all last chapter. So we add 3 to both sides. This goes away. 97 plus 3 is a perfectly easy number. We get 100. 100 equals 5 times some number. So 5 times what number would give me 100? If you're not sure, you can divide both sides by 5. And n on the right is left alone. And 100 over 5 is 20. So what does this mean in the context of this problem? It means if we were to list out these numbers and keep going up and up and up, when we hit 97, it will be the 20th number. It'll be the 20th term in the list. So 97 will be on one of the points, one of the numbers given. How far along? 20th in line. So our options, we know C is what we're looking for. That's right on the money for 3D. Okay. So 4A is one more problem to think about. We're given a different sequence so we can look at this and understand what's happening. So they tell us, write a function to represent this sequence. So we've got 4 numbers here. They say, given some context, this is the total number of ounces that a bag weighs after each additional newspaper is added. So we're putting newspapers in a bag and we're looking at how much they weigh. We're listing those out. So we want to write a function to represent this. So here's our sequence. And our function we'll start with the same process we started with last time. Our blank equation for any arithmetic sequence is given here. And of course, this is in everyone's notes from the beginning of this section. So this will be our blank equation. Now the two things you need to know to solve for the equation: what is the first term and what is the common difference? What is D in this equation? Okay, so the first term we know is 12. And the common difference between these, how much is it increasing each time? Was going up 11. So given those two things, we can write this function. So we notice it's changing up 11 every time. Not bad. The common difference is 11, we said. So now we'll plug in. So first term, 12. Common difference, 11. Given those two things, we'll plug in. Now we need to distribute this 11 to both things. So we get 11n minus 11 when we multiply. With one more step, we take now this 11n we want to write first. So we'll have 11n, and then when we combine 12 and negative 11, 12 take away 11 just leaves you with a positive 1. So when we simplify, you get 11n plus 1. Now notice this one, first term has the variable. Second term is just a number, so there's nothing we could do to combine those. That is as simple as it's going to get. So the answer in simplest form, this is that function. Don't let the word function throw you off. They're just asking for the equation. And here it is. To find any term in the list, you do 11 times the number and you add 1. Done. That is the rule for that example. So part B of the same thing, and don't worry about all these words. Just as long as you have this function down, you need to make sure then that you have the instructions. So we want to graph this function and determine the domain. So the first part is graphing, and remember what we said about graphing. The x-axis will be our term number, just n. The y-axis will be the value of the term a sub n. So we can graph the first 5 points. That will be given here. Notice the x is just counting numbers, 1, 2, 3, 4. We're listing the number of the terms. And then the y value is the terms itself, the numbers in the list. 12, 23, 34, 45. 12, 23, 34, 45. So those are there. Now, once we have that, what does the question ask us? It says determine the domain. Now this word domain was in our vocab earlier this year. Domain means any and all x values. So when it says determine this domain, it's asking you what values of x are there. So we know that we have 1, 2, 3, and 4 as x values. And we also know it's going to keep going up by integers of 1 every time. So what is our domain in a sentence? How would we say that? The domain of the function is the number of newspapers added to the bag. So we could have 0, 1, 2, 3, 4, and go on and on and on forever. So that is the domain, all of these whole numbers. So please have some image of this graph, and then saying that the domain is these counting numbers. The domain will always be these whole numbers, okay? That doesn't change with these arithmetic sequence problems. So have that down as we progress with this section. So the arithmetic sequence given here, and this one is actually 4C. So 4C, tells us this arithmetic sequence represents the total number of ounces a box weighs. Now we're adding salad dressing. So that's just some context. The math is the same. So to write the equation, we want to write the function. We know we're going to start with our blank equation. A sub n equals A sub 1 plus n minus 1 times d. Okay, now the two things we need to find. One, what is the first term? The first term in our list is 22. The second thing we need to find, what is our d? What is our common difference? How are these changing every time? And if we look, it's going up every time with some simple math, you can see it's 18. So now we'll plug these two things in back into our blank equation. And I'll do this in red as we change the numbers. So A sub 1 is 22. Our common difference is 18. Now given that, everything else is the same, and we can go ahead and simplify this out. So we have 22, a number by itself. Over here we have this 18, and it needs to be applied and distributed to both the negative 1 and the n. So what are we going to get here? 22 stays the same, plus 18 times n is 18n, and negative 1 times 18 is a minus 18. 22 take away 18 is 4. And 18n can't be changed. And I want to write my variable first, so I'll do that here, and then leave the plus 4. So looking at these options, we now know any term, a sub n, any term, can be found by multiplying 18 times a number at 4. So which option is right? No, no, and no. B is our correct answer for this 4C problem. Now 4b asks us to graph this function. So don't worry about the words again, just jot down this image. The key that we want to focus on as we're remembering our x-axis is the number of terms and our y-axis is the terms themselves. We want to jot down what is the domain of the sequence. In other words, what are the x values that go across the bottom? Well, we see it starts at 0. So I know my domain will be equal to, and we'll start a bracket, we'll insert 0, we see counting numbers going up, 1, 2, 3, 4, and dot, dot, dot to let them know that we know it keeps going on, close the bracket, and then this is the end of our domain. All whole numbers is a domain. So given these options, we see B skips numbers, C, these are the numbers in the sequence, that's not right. And D, these numbers are just random. So our solution has to be A, those are the x values. Domain means x values. So A is our answer there. So given all this, you can solve this section and do well as we work with these arithmetic sequences.